Hey, what's up, guys? Welcome to another video. And let me just close Discord. So, weekly contest 426. I need plus 55 delta to reach 2500. So, yeah, let's go. Okay, good luck. Good luck, everyone. Greater equal to n. Okay. Hope it's fine. Okay. Special. Some of these special numbers. So an outlier is defined as neither. They may share the same value. Potential outlier. So hmm. So if we remove an outlier, then if the sum is even, okay. So if sum minus if I is odd, then continue. Otherwise, so if k is largest, okay, 10, 4, 5. Hmm, if I 10, 4, 5, 35. Hmm. Should I do Q3 first? Let me try to read this first and see how Q3 is easier. So two undirected trees. So node U is target to know if number of edges is even. Maximum possible target to node 1 to node 1 to node I. It's an I, right? Okay. So it doesn't matter. Doesn't matter that much, does it? Let's equal to k. K is 1,000. I can just brute force this, can't I? I'll think about this. You know what? These are actually two separate problems, so I better solve Q3 first before I get too carried away. Can I see the leaderboard? Wait, isn't it just greedy? So you try. So you fix. I'm trying to understand the example. So the first graph. Okay. So we try. Okay. So then. 97988. 6. Okay. Now, so I have to basically extend this idea a little bit. Okay, so I'm no longer, you know what? So now I want to figure out the parity. Okay. So we cannot brute force this. We have to do a reroute DP. But once we do that, the idea is kind of the same. Okay. So I need, so I'm not gonna worry about this for now. Um, Hmm. Okay. Hmm. Let me reroute this. Okay, so okay. Uh, so it's like self, you. Hmm. Hmm. So what if parent answer these? So if the current, so if that's the answer and current PR, so I need more info. And so it's like her plus the answer of PR minus PR. My DP correct. So that means this is fixed if this node is at zero. So like, how do I even do? How do I want to do this? Wait, wait, hold the heck up. I don't have to do this. Mm, mm, mm. So if PV1 of I um then I would do这是吸引器 one。 87788. Okay, so I'll go with the problems. Hmm. How do people solve this? Okay, yeah, I'll go over it. So Q3 and Q4 are actually a lot different than you might think. Wait, what am I doing? So this one just brute force. You can just brute force. Now the reason being that if you look at let me go to Wolfram Alpha. If you look at log 2 of 1,000, you can see that wait, why did I add 1,000? So that means the highest exponent is 9. So that means you can potentially go up to the power of 10 because we're looking for power of 2 minus 1, so to the power of 10. So we don't actually go up by that much because that is like the 1023 is the maximum. There's a maximum number we can reach. So we can afford just 1,000 iterations at most. Now, number two is there's a tiny bit of a tricky thing to consider, but the basic idea is if you know that there's an outlier, right? So let's say we ignore the outlier. So what do we have left in the array? We have one element that is the sum of all the others. So that means, for starters, if the number, so for every single number, you try to make an outlier. So that means we add up sum of array, you remove this supposed outlier you fix. So if the remaining sum is odd, then you know it's not possible because you basically summed the two values, two of the same values, and always get even number. So if it's odd, it's out. Now, this k is the sum of this k is like the sum of all these special numbers. So now the reason I have this condition is it was actually based off a test case I failed. But essentially, we want to see if there can be a case where the outlier is the same as this value k, and that's a little bit complicated because we have negative numbers. So so if we so we have more than one of this outlier, then so if everything else works and we figure out this outlier turns out to be the same value, they want to check if there's another one. Otherwise, you don't have to. So that's the idea. You fix each number to be the outlier, then you check if it's possible. Now, for Q3, you can basically do a brute force. So let's equal to k. So what this means is for the second tree, you can pick you can pick like the best starting node for the second tree. So you start with this node. Which node has the best reach with a distance of k minus 1 because you're connecting. The idea is you find the best starting node for second graph and you connect that to whatever node the query is asking. So if it's asking for node 0, you connect that starting node to node 0 because that minimizes the distance you have spent so far. So you brute force to figure out which is the best starting node. You can just do a DFS or whatever. And then you do it twice. Well, I have this nice DFS function. I do it twice. So I figure out for the best starting node, the distance is at most k minus 1. And then for this first tree, I would have a distance of at most k, so you then just add the two together. So you can just brute force this. And this one is a little bit special. So this takes a little bit more explaining to do. So instead of caring about at most k, we care about the parity of the number of edges. So we can basically do a DFS. So we figure out several things about each node. We figure out what. So if we fix the tree at 0, we can figure out for each node what parity it's on. What is the parity of distance from 0 to this node? And then what is the total count of nodes of that parity? And just do that. So then for the to answer this, even though we based everything off at root 0, since we kept track of the parity of each node, we can simply count number of nodes that have same parity as this current node. And this maximum part, the idea is that so we know for the constraint the number of nodes is at least 2. So that means whatever node we're on, we're guaranteed to have at least one neighbor. And the neighbor is going to have our, well, okay, maybe thinking, well, why did I just totally disregard the parity of current node here? Well, for a second graph, when we compute this, we only care about the count of the parities. You can basically show that you can make it work. So I know for here we fix our both trees at 0. So that means for tree 2, everyone's parity is also based on node 0. But you can rotate the graph in such a way that you can pick any of the parities and give the maximum count. You can think about that a little bit, but yeah, that's the idea. I thought I had to do some reroute DP. Thankfully, I don't have to because I hate reroute DP. But yeah, those are the problems.